Hello, CIS-11. This is my video on Lab 3 Exercise 3 fix. I received a few emails regarding your program wasn't giving out the proper result. So I wanted to take this opportunity to go over the code, and I did modify a couple of things for Exercise 3, Lab 3, so that way it will clear up. So let's take a look at the editor for LC-3. In exercise 3, we were given a task to apply the function t is equal to a plus b plus c minus 9. And in the original program, I had initialized a at this address, b at the adjacent address, which is 3103, and c at 3104. And then the result, we want to place it at 3105. But it turns out that if you are assigning C with a value that's less than 9, you're going to have an overflow. So what we need to do is we would need to remove the addresses from the code. And this is only part of the comment. And we will go through each of the line. And then at the end, instead of the fill, we're going to use block word. And I'll explain why. So in this program, we're going to originate at hex 3000. That's where our program is going to start. We're going to clear out our register that we're going to use. So we are going to use register 1, and we're going to load A to that. We're going to use register 2, and we're going to load B to that. We're going to use register 3, and we're going to initialize C for register 3, and then register 5 is going to hold our result. So when you're doing an AND instruction here with the register, you would go AND R0, hex 0. That's going to clear the register. That's going to initialize them at 0. Then next, we're going to do a direct load. So we're going to load the label A, which is our variable A here. We want to be able to load that to the first register, which is register 0. On the second load, we're going to load the register B. So B, the label B is going to go into register 1. So load R1B. Then the equation tells us to take A plus B. So at this point, we're going to do an add. And A is at register 0. So you're going to take that and you're going to do an add R1. This is where the result for A plus B is going to be. And we're going to take B, which is in register 1, plus A, which is in register 0. So at this point, our register 1 is going to hold the result for A plus B. Then next, we're going to move to the next part of the equation, which is going to be C. So we are going to use our register 3. We're going to load register 3 with the label C. So here, C is loaded to register 3 by doing an LD R3C. And you can see that in my comment here. So the original program, I pretty much did the same. Then after that, we're going to take 9 and we're going to load it to the register 2 because this is a constant and we're going to make 9 into a signed value. So we are going to go ahead and add 9 to register 2 and then store it back into register 2. Then next, we're going to do the ones complement. So at this point, we're going to get ready to make 9 into a signed value or the negative value. So we're going to do a not R2, R2, because 9 is currently in register 2. And for the ones complement, we are going to do a not for R2. After that, we're going to add the register 2 with a hex 1 because now then it becomes the 2's complement. So on the next step, we're performing the 2's complement of R2 or register 2, which contain negative hex 9. So by adding 1 to the register 2, we're going to put the result into register 2. So you're going to do an add R2, R2, X1. Now, since we have C and we have -9, we're going to add those registers together. So we would have C -9. So C is currently in register 3. So we're going to take register 3, we're going to add it to register 2, and we're going to put the result in register 5, which is where we're going to load the label T. So you're not really required to load this. You can store it back to label T. So after we added register 3 with register 2 and put the result in register 5, we're going to add everything together. So you would have A plus B plus C -9. So our C -9 is currently in register 5 from the previous line. So you would take C -9, which is in register 5, and you would add it to register 1, which holds A plus B. So coming back to this line here, we see that A plus B is in register 1. So we take register 1, add it with register 5, and we're going to store the result back into register 5. So the result is in register 5 at this line. Then after that, we would take the result and we would store it out to the label. So you're going to do an ST, as here we would do, earlier we would do direct load. So now we would do a direct store. So you're going to take the result from register 5 and you're going to store it back into the label T. And that would complete our equation. So now we would do a halt. Instead of using the fill here, I wanted to use block word for each of the variable in our equation. The only reason why is that if you're using a fill address with the instruction for the register, in the case where if you are running into a negative number or when you operate addition and subtraction, if it's larger than 5 bits, it's gonna have an overflow. So what we would do here is we would, instead of using the fill, you would use block word 1. And what that does is it's gonna use the adjacent address after all the instructions that's part of your code. And I will show you that next. So the reason why also is because when you're using C -9, so if I give C as 7, 7 minus 9 in decimal value is going to be -2. And if you take your programming calculator, so if we open up our calculator and we choose the programming mode or the programmer mode, if you have a decimal 7, let's say that we would pick a number to test our equation, and C, we wanted to choose that as a 7. So if we use 7, subtract 9, we know that it is -2. So bring it down to the word size. A -2 in hexadecimal is FFFE. And when we were using the fill address, the result, it's not really able to store the output because this is bigger than 5 bits. Each of the hexadecimal digit is 4-bit. So if you have 4 digits, it is larger than 5 bits. So that's why we were not able to see our result where T was located at a certain memory address. So when you're using the block word, it's able to store the result as a word is 16-bit. And so with block word 1, that's going to allocate 16-bit to store your value. So once we finish our code, we simply click assemble, making sure that you check for error here. So in my case, I have no error. Then I'm going to open up my simulator. And if you are retesting the program, you would reinitialize the machine. Then we're going to load the program. So click File, Load Program, and locate where your program is. So I labeled this as lab3ex3 fix. And once I assemble, I have an object file. So I'm going to go ahead and open the object file. And before you start setting the value, I want to show you that in the program, you would see that because we're using block word, instead of further down in the memory address that we would select in our code, like what we've seen in the original program that we did, when you're using a block word, it's gonna use the address at the end of your program after halt, right? Sequentially when it gets here. So when you look at that, your address is actually for A is actually after the instruction halt. And then B is subsequent to that, and C and T. So here's A, B, C, and T. And so now in order to set the value, you can simply double click where A is. And so it would tell me that this is the location for A. Then we would go ahead and put in the hex value. So let's say that I want to give A, my variable, a value. I would choose a 5, and I can simply click apply and OK after I put that in. And a hex 5 is equivalent to a decimal 5. So for the simulator, it's best that you use a hexadecimal value. So once I put in my value, apply, OK. Then I can simply double click the next one. And as you notice that it also placed a 5 here for my label A. And then on the next one, I'm going to go ahead and put in a 6. So it is, B is now initialized at 6, as 6 or hex 6. We're going to click apply and OK. And then for C, because the equation is A plus B plus C minus 9. And C, we want, so let's say that I give it a hex 9. So you double click where C is, and you would choose 9, apply, and OK. Now we wanted to see if it can calculate this and put the result in T after we run the program. So we had given A 5, A is equal to 5, B is equal to 6, and C is equal to 9. So A plus B is going to give us 11. 9 minus 9 is 0, so 0 plus 11 in decimal, so it's going to output hex here. So 11 decimal, and you would check for the hex equivalent at T. So after we had set our values, we can simply click run. And as it runs, it's going to move down further. So what you're going to do is you're going to jump to the location. So in the jump to, you're going to clear that out, and you can go jump back to the beginning of the program. Because it's such a short program, you should be able to see all your variable or your label near the end. So we're going to jump back to hex 3000. And as you can see, this is the beginning of our program. After it ran, we already set the value earlier. So A, B, and C values are still there. But as you can see, we would see T, it's putting hex B there, and hex B is equivalent to 11 in decimal. So we would see that it is the correct output, because if you plug in the number 5 plus 6 plus 9 minus 9, it's going to be 11. And so, and you can pick any number that you want to set for the values. So you can reinitialize the machine, load the program again. And once you load the program, you would double click where the variable or the label is. And then you can input the hex value for that variable and click apply and OK, and so on. And then we want to set the value for A, B, and C. And then we would run the program and we would check for the result at T. So we can see that using the block word, that it's able to output for T, because if you're using the regular address, what happens is it has overflow and it's not able to input, it's not able to output the correct value. So it's only going to show 0 at the end. And this should address some of the questions some of you had sent me via email or Canvas message regarding why is your program outputting 0, only because it's overflow. So let me know if you have further questions, and I hope that this clears up some of the concern and question you have with the prior lab. Thank you for watching the video.